Hi guys, Dr. B here. This is a lecture on stoichiometry. Now, stoichiometry is the thing we've been building up to over the past several months with dimensional analysis, sig figs, and balancing reactions, etc. So it's a part of chemistry that involves using relationships in a between reactants and products in a chemical reaction. So, like I said, these are the four keys you need to be able to do: dimensional analysis, balancing, moles, molar mass, following your sig fig rules, especially. So, a couple of things in terms of balancing, you need to, or doing this is knowing how to convert moles to moles with something called the mole to mole ratio. You have to make sure your equation is balanced correctly because if you can't, then you're going to mess up this important ratio. So first you have to know what you're looking for and what you're trying to find. So like I said, the mole to mole ratio comes from the coefficients of your balanced chemical equation. So that's how you're going to relate two things when you are trying to convert them in a stoichiometry problem. So I'll show you how to do that. So like I said, first you have to balance. So my coefficients are 2, 1, 2, 1. This is my known because it has a number and a unit. My unknown is what I'm looking for. How many moles of silver? So I'll start off with my known. 0.295 moles of copper. All of these will be over 1. So if I'm converting moles to moles, that will be 2 steps. So how do I do that? We're going to use something called the mole to mole ratio. So I told you it's going to be 2 steps. So this unit up here has to be directly on the bottom. Then I'm going to convert that over to moles of Ag. This is my mole to mole ratio. The numbers come from the coefficients, just the number that's in the front. So 2 moles of Ag and then 1 mole of copper right there. So to figure that out, you need to multiply 0, 0.295 times 2. That's going to be 0.59 over 1 because that's right there. I divide, I get 0.59. However, you have to be mindful of your sig figs. So 3 sig figs, so this should be 0.590 moles of Ag. Alrighty, so then how many moles of carbon dioxide are produced in the combustion of 0.750 moles of hexane? So we're going to balance this really quick. So it's going to be, I have 6, so put 6 here. I have 14 H's, so I'm going to put a 7 in front of there because 7 times 2 is 14. So right now I'm going to put a 1 in the front of my C6H14 because I'm done with that. And then I need to now figure out how many O's I have. So I look on my product side. I have 6 times 2 plus 7 times 1. That is 19 O's. So right now I'll put a 19 in front of my O2 and multiply everything else by 2. 2, 12, 14. So again, I start off with my known. This is moles to moles, so it's going to be 2 fractions. So moles of C6H14 on the bottom, moles of CO2 on the top, because that's what I'm looking for. So I'm going to take these numbers. It's going to be 12 over 2. So I'm going to do my math. 0.750 times 12 is my numerator. 9 divided by 2. So 9 divided by 2 is 4.5. However, again, I have to be mindful of my sig figs. So it becomes 4.50 moles of CO2. All right, so I'm going to keep the same coefficients. Now I just want to convert this. So let's use 0.750 moles of C6H14 on the top. All right. So mole to mole is going to be 2 steps. So it's going to be 2 moles of C6H14. Then on the top will be 19 moles of O2. So 0.750 times 19 divided by 2. That will be 7.125 3 sig figs. So 7.13 moles of O2. Okay, so how many moles of ammonia are consumed and 1.35 moles of O2 are consumed? So it's going to be 2, 2. I have 3 H's here times 2, so it's going to be 6 H's. And then I look at my O's, I have 5. So I'll put this number here, multiply everything else by 2. 1.35 moles of O2, converting that over to moles of NH3, 2 steps. Five moles of O2 on the bottom. On the top will be 4 moles of NH3. So 1.35 times 4, 5.4 divided by 5. 1.08. Luckily, that's 3 sig figs, so moles of NH3. I'll use my same coefficients, 4, 5, 4, 6. Then I'm going to use the same number, 1.35 moles of O2. Convert that over to moles of water. So 5 moles of O2, then 6 moles of H2O. 1.35 times 6. Oops. 8.1 divided by 5 will give me 1.62 moles of H2O. So something to keep in mind, we just did moles to moles. We also have to do moles to grams, grams to moles, grams to grams afterwards. So if I'm converting grams of one thing to moles of another thing, that is 3 fractions. Moles of something to grams of something, that is also 3 fractions. Grams to grams will be 4 steps total. And I'll show you how to do that for both. All right, so carbon reacts with sulfur dioxide to form carbon disulfide, carbon dioxide, the following reaction. How many grams of CO2 will be produced if 0.852 moles of carbon is completely consumed by sulfur dioxide? So first we balance. I have 2 S's, I'll put a 2 here. I have 4 O's, I'll put a 2 here. Now I have 3 C's. 0.852 moles of C over 1. So 2 moles of CO2 over 3 moles of C. I'll try to convert to CO2. 44.01 grams of CO2, 1 mole of CO2 on the bottom. Alrighty. So 0.852 times 2 times 44.01 is 74.99304. And denominator is 3, so divide both. I'll divide this by 3. I'll end up with 24.99768. 3 sig figs, so 25.0 grams of CO2. Elemental phosphorus reacts with chlorine to form phosphorus pentachloride with the following reaction. How many moles of CO2 will be consumed if 5.50 grams of PCl5 are produced? So 252. Okay, so my starting fraction is 5.50 grams of PCl5. Grams to moles and two different things, it is 3 steps. So I want moles of Cl2 in the end. So this unit here has to be in the bottom, grams of PCl5. So this right here, this is my molar mass fraction. In 1 mole of PCl5, it equals the molar mass of PCl5. So since I'm in moles of PCl5, I'll put this down here. Now I'm going to use my coefficients to get my mole to mole ratio. So 5 moles of Cl2 over 2 moles of PCl5. So 5.50 times 5 is 27.5. And then the denominator is 208.22 times 2. So 416.44. I divide both numbers. I get 0.06603. That becomes 0.0660 moles of Cl2. Aluminum metal will react with bromine to form aluminum bromide. Coefficients are 2, 3, 2. What mass of Br2 will be consumed by 0.200 moles of Al? So I'll start off with 0.200 moles of Al. Convert that over to grams of Br2. That will be 3 fractions. So moles of Al on the bottom. Notice I want to be in grams of Br2. So in order for me to switch, I have to use my mole to mole ratio. So 2 moles of Al, 3 moles of Br2. So now that I'm in this one over here, I cannot use those coefficients anymore. I can only say 1 mole equals the molar mass of Br2, 79.9 times 2, which is 159.8. So I'm going to multiply my numerator, 0.2 times 3 times 159.8, 95.88 divided by 2, 47.94, or 3 sig figs, 47.9 grams of Br2. That was moles to grams, and that's 3 steps. This next one here is going to be grams to grams. We're going to use the mass. So we're going to use 47.9 grams of Br2 and convert that over to mass of AlBr3. Same reaction, same coefficients. Grams to grams will be 4 steps. 1, 2, 3, 4. I'm ending at grams of AlBr3 over here. So in 1 mole of Br2, That is 159.8 grams of BR2. Notice that my grams are here. Put them down here again. I want to get rid of those, so I'm using my molar mass fraction here. I am in moles of BR2. I have to get to grams of AlBr3. I apologize. So I'm going to put moles of BR2 down here. Then on the top, I will put moles of AlBr3. So I'll put my coefficients: 3 moles of Br2, 2 moles of AlBr3. Then I'll convert that over to grams of AlBr3. Molar mass. So it's going to be 26.98 plus 3 times 79.9. So 266.68. So I multiply across. 47.9 times 2 times 266.68. So 25547.94 divided my denominator, which was 159.8 times 3. Oops. 479.4. I will divide those two numbers and it'll give me my answer finally. Oops. What am I doing? So I get 53.29 for my answer, but I'll put this down here now. To have the correct sig figs, it will be 53.3 grams of AlB. Alrighty then. So that's it for now for stoichiometry. If you have any questions, please let me know. Thanks.